So let's just talk briefly about a typed dictionary. It looks very similar to a name tuple. I think it has a few deficiencies in comparison to a name tuple. So you have to be using Python 3.8 or newer to get the type dict, and we can import that from the typing module with typed dict, just like we did with name tuple. And instead of deriving our class from name tuple, we're going to derive it from typed dict. But noticing here that just as before, we can put in type hints here, but noticing we cannot put default values, which I think is a substantially worse version than already. So when we instantiate our default state, we have to put the default values here. I don't really like that, but you know, it's kind of it gets you basically the same thing. Syntactically, I like this state.board accessor values that you get with a name tuple. It looks more like an object. It looks more like a field access. And here I'm saying state board. I'm using the dictionary access of dictionary keys, and I don't quite like that. It's more typing, and it's just another way of it's just more typing. I don't prefer this. The other thing is, so this is what it looks like to use this code all the way throughout, and I have included a solution that is based on the type dict, and it passes and it works essentially the same way. Just there are things about the name tuple version I prefer better. One thing is with the name tuple, we were returning, I would say return state underscore replace, and I was able to replace that one value. Here you notice, because this is a dictionary, I am able to directly modify the state. So I can say state quit is equal to true, and then I return state. I don't prefer this. I like the replace. I like being able to return state replace all in one line without, and this is 2 lines of code to do essentially the same thing. I just think the other way is a little more elegant. Here again, I'm also directly modifying the state object, and I prefer the safety of kind of being really explicit about that underscore replace, and just being really blindingly obvious in my code that I know I'm replacing these values and I'm returning this new state object. Otherwise, it's essentially the same idea as with the name tuples. So in the end, mostly what I'm hoping that you get from this version of the program is that you're thinking about state. And the way that I've shown is somewhat advanced, maybe. Certainly maybe not the way that you might have thought to do this. Like it would be very common, instead of having this state idea that gets overwritten each time through this while loop, you might instead create a bunch of global variables up here. Well, maybe not necessarily global, but outside of the scope of this, outside of this while loop, you might declare variables for each one of those things, like the error and whether or not it's a draw and who the winner is. And then I think that it leads to you might update the error and forget to change the player, and it could lead to very subtle bugs. I think that the complexity of understanding this data structure and then moving through this, replacing the entire data structure each time through, is less prone to those kinds of errors. It would be even worse if you declared the variables up here outside of main, so that they were, for instance, available inside of each of the individual functions. That would be the very worst, I think, possibility that you could come up to do with this. I would mention that my entire take on how to program this is really taken from the Elm programming language, which I've used on a number of projects to create user interfaces, a web user interface. And there's this idea, the Elm runtime keeps track of this state, and whenever the state changes, the whole cycle just kind of starts again. And so the view of the state is always based directly upon whatever is the latest idea of the state. And so that was very much an influence on how I chose to write this. You may have a completely different idea of how to write an interactive version, and that's totally fine. Hopefully you found ways to test each of the pieces and to feel like you really understand what you've done. So some other ideas. Maybe you want to, for when they quit, you want to bring in some better insults. You might go back to our Shakespearean generator. Definitely, this would be. I mentioned in the last one that you might write hangman. I would definitely recommend you try this idea with hangman, and I have a version myself. If you want to dig through my GitHub repository, you can find it. It's a little rougher than this, but it's the same idea. And another thing that you could do is write another meta while loop, so that instead of just quitting when it's done with a game, it prompts the user to see if they want to start a new game without having to restart the program. Think about how you might add that additional loop. So in summary, I hope that you've seen why type hints can be useful. You can use them to annotate the functions, function parameters, and also the return value of functions. You can use them to annotate variables, and we use them inside named tuples to annotate the fields. They're really, really useful. But it's important to understand that Python ignores these type hints. It will recognize them as syntax, valid syntax, but it just doesn't use that information. So you have to use MyPy, and perhaps other tools in the future will also use this to help us write better code. The name tuple is a lot. What you get from a name tuple is something that looks a little bit like a dictionary, but it is immutable, unlike a dictionary. That could be good, that could be bad, depending on how you want to use it. Both the name tuples and the type dicts basically allow you to create these novel types, and with these fields that are defined, and that you can add type hints to, and you get a lot more information from tools like MyPy when you use structures like this. We used a name tuple, and I really like that because there's just a lot about the syntax and the immutability that I really liked. And the last thing is that it is difficult to write integration tests for interactive programs, but it's still possible to have those small functions and the unit tests that we can use. I don't think in your career you're really going to write a lot of interactive programs like this. They're probably more going to be things more like command line applications that run from the beginning to the end, or they're going to be something like maybe a Django web server that's going to be just running like a daemon, and that's going to have functions that are going to get executed given certain actions that the user takes. So I hope you really learned a lot. That's the whole book. If you made it this far and you've actually watched all these videos, kudos to you. That's an incredible amount of work, and I'm honored that you would choose to spend so much time working on this. Thank you.